course here, 256 over 64 plus 180 over 36. Will you give that a try, please, and let me know what you come up with there? We will need that other formula sheet for other stuff, so let me also look for that.
Plus.
Yes.
3. Yeah, I got 3.
Square root of 9 or 3. So you can check that. I'm pretty sure that's correct. Just looking here again to see if you actually get this one. Oh yeah, you do get it there. That's good. I did find it on that reference sheet. You guys are in chapter 10 now, looks like.
Yes.
Didn't even. All right. Okay, back to the questions here. So number 3 is. All right, you may need to use the appropriate technology. All right, here we go. All right, so it says that if the standard error is 2, what is the margin of error at the 95% confidence interval? All right. So you really need these formulas. I know that that's not exciting, but they really are needed here. So the confidence interval, just snip that in so you can see it. Formula. All right, let me snip it in here. Okay, so it's x bar 1 minus x bar 2. That's 47 minus 43 plus or minus. Now at the 95% confidence interval, that's where we were doing this before, where you're looking up the z values from the area 0.95. Okay, and by now you should have a pretty good idea of these minus 1.96 plus 1.96. That's the z value. Now this standard error is this part in the square root. That whole thing is 2. So the margin of error here is this part. This is the margin of error in the confidence interval formula. So just got to multiply 1.96 times 2 for that.
$3.92.
Yes. Again, probably a good idea to check these as you go. I'm sure you get a couple attempts so we can confirm a wrong answer or right answer. All right. Yeah, this is the part of the course where it gets a lot more complicated. Just keep that in mind. 2 samples are always more complicated than 1 sample. Double the work in a lot of cases. Okay. This one says the point estimate is the difference in means is 6. That comes from the 57 minus 51. That's the difference in means. The margin of error is 5.88. So the margin of error is always added and subtracted to the difference of the mean. So it's always, in this case, 6 plus or minus the margin of error. So in your problem here, it's 6 plus 5.88. 6 minus 5.88. So that was that whole idea of this formula up here. Let me grab it again. More generally, just because I think it'll mean more to you. This part is the difference in the means. And then everything to the right of this is the margin of error.
Okay.
All right.
So what would X1 be?
Well, they're giving you the difference in the means. The difference in the means, they're telling you when you subtract this, it is 57 minus 51. And they're saying that equals 6. So it's 6 plus the margin of error, which is 5.88, 6 minus the margin of error, which is minus 5.88.
Okay.
So if you can, go ahead and calculate that again. doing the calculations you'll find will help here on the exams. What do you have for an answer?
I sorry, I did it backwards.
It's okay. Just go ahead and redo it there.
I got the 0.0 or 0.12 to 11.88.
Good. Very good. All right, here is the next one. Okay. This one, we're kind of seeing the same thing over and over again, right? It's some table. They give you the means, they give you the sample size, they give you the variance. Okay. They're asking you different things. This time they're asking for what's called the test statistic. And you're used to the test statistic being Z. And that is no different here. That is the test statistic. So let me go back to your formula sheet. You'll see that Z equals, snip this in here on the right. Z equals X bar 1 minus X bar 2 minus D0. Now, for now, just ignore that minus D0. Probably won't come into play ever in your course, but your X bar 1 is 58. Your X bar 2 is 52. I'm just grabbing this from the table there.
What would sample size be?
There, number of, that's like N1 and N2.
Okay.
This 272 is sigma 1 squared, sigma 2 squared.
Okay.
Okay. And so you have everything you need here. You have 58 minus 52. They're telling you that's 6. You already know that. They're also telling you the standard error. This part on the bottom is the standard error. Or you can calculate it if you want, but they're saying, hey, here's the standard error. All right. So you literally are just taking the difference in means, 58 minus 52, which is 6, and then dividing it by the 3. Which is 2.
Okay. Okay, I got that. Thank you.
All right. Number 6. Okay. The test statistic is 2.5. We're just going down here to the bottom here. In a test of whether or not the population average salary of males is significantly greater than that of females, what is the p-value? So the wording here is important. When it says significantly greater than, they're referring to your null and alternative hypothesis. You saw that in the last chapter. So this is the fact that they're saying mu is greater than some number, or it's really mu1 minus mu1 is greater than mu2. But notice it's a one-tailed test. So the greater than is one-tailed. You draw your normal curve. Here's 2.5-ish. We just want the area to the right of it. Okay. So how do you find the area to the right of a Z value on your calculator? Do you remember that function?
Was it in sorry, I was gonna say the wrong one.
That's okay. It's like Wheel of Fortune. The letters start coming up. Normal CDF, you got your lower 2.5, your upper, your mean is 0, and your sigma is 1. So if you got a calculator, go ahead and calculate that for us, please. Let me know what you come up with.
0.00062. The first one.
Okay.
Yep, that's right.
Okay. Okay, here we go. Next question here. It says find a point estimate for the difference between the two population means. Here are your two population means.
Okay.
Even though it says point estimate, they just mean take the difference between them.
Okay.
What is the difference between the two means?
1 second, sorry. Would it just be 1?
It is just 1. You got it.
I
All
don't
right,
know
now
why
a really
I don't know why I calculated it. I could just looked at it.
well, you just for comfort. I mean, you just like setting 4 alarms when you're going to the airport. You want to make sure you're on time. The thing that's really subtle here is some word changes. Okay,
Okay.
population variance,
Mm-hmm.
sample standard deviation. Okay, whenever you see sample, you're going to be using a T. Whenever you see population, you'll be using a Z.
Okay.
That should have been sort of made really clear, shouted from the mountaintops in your classroom. Okay, so new problem here. Again, they're giving you the sample standard deviation, that's T. Okay, and they're telling you the point estimate for the difference between the two population means is 0.5. That's 17.75 minus 17.25. Okay, but this time they want the test statistic. They want the T. Okay, this is where you got to know the formula. There's no way to do this otherwise. Actually, I take that back. Your calculator will do this. We should do that. So let me, I just need a little, probably 2 minutes here because I'm on a different setup than usual. So I don't have my calculator stuff ready to go, but give me 2 minutes here. It's going to be under second or stat test, 2 sample t-test. So we'll get that going here, but let me get my thing out. There it is. Oh, we open the folder, All right, and let's maybe I should download the whole folder. Download. Okay, do you have yours out, your 283 out?
Yep.
Okay, so I'm going to share my calculator here. All right, so go to stat test 2 sample t-test. Okay, the reason it's a t-test is the sample standard deviation. You have to choose whether you're doing data or stats, and you want to choose stats because we don't know any of the data. Okay, now notice it says X bar 1.
You hit second stat.
Yes. I'm sorry, stat test, not second.
Okay.
Stat test. And you want to choose the 2 sample t-test. Number 4 there.
Okay, yeah, I got that.
Okay, and then you got to choose whether you're using data or stats. You're using stats because you don't have any of the data.
Okay.
And it kind of helps you. It says, well, you need an X bar 1. Your X bar 1 is 17.75.
Okay.
Your SX is the sample standard deviation of 1. That's 1. Your N1 is 85. Your X bar 2 is 17.25. Your SX2 is 0.95. And then your N2 is 40. All right, and then we actually don't care about this part for the next one. Have you guys talked about pooled estimators yet?
I'm not sure.
Yeah, I'm not sure. So we'll just calculate it as is and see if one of the answers is there. All right, and there it is. So that is, there's a lot there, but this is everything you need to answer this question. So we're just looking for the t value there.
Okay.
So you see the t value is 2.70.
Let me scroll. Yep.
And then if we go back to our other screen, you can see that that is that one right there. So kind of just like before, you can use the calculator for almost every problem. Just got to get you comfortable with like
It's
what to
just
do.
confusing using the calculator.
Yeah, it takes some, there's a little bit of a learning curve, okay? But no reason you can't do it. Okay, number 9. So number 9, let me snip this in here. Again, notice the sample standard deviation is given. That means this is a t that you're looking for. They're giving you the t value, okay? But what I'd like you to do is go to the stat test to sample t-test
Same one, right?
and enter this information one more time. And then you'll see you'll see 3 options: not equal to, I don't know, less than or greater than. And we're going to talk about that in a moment. But would you mind going there and calculating?
Yep. So X1 would be 18.75, right?
Yes. Yes.
And then 1
Is it should be really similar. I mean,
yeah.
only
7
the red values changed, it looked like.
then skip all the other stuff, right?
So we need to talk about this not equal to, less than, greater than.
Okay, yeah.
So right here it says, in order to determine whether there's a significant difference. So difference means two-tailed. So you want to select that one there when you're choosing it, because that's going to affect the p-value.
Okay, and it's got a U2 behind it.
That's fine. That's fine. Just make sure it's got the not
Okay.
equal to. And then what you're looking for this time is that p-value that's below the t. So when you get that on your screen here, let me know what you see.
0024. Yeah.
Second one here.
Yes.
Okay, good. You got to be able to enter that on your own. You got to be able to work this out here.
Okay. Cool.
Because guess what we're going to do in the next problem? Exactly the same thing.
Okay.
All right, so here you go. Number 10. There's so lots of words here, blah, blah, blah. But like, you should focus on, are they giving you the population standard deviation or the z or the sample? And this time they're giving you the populations. This is going to be a z. So this is going to be different. It's a stat test to samp z test, not a t test. And it's because the population standard deviation is given. All right. So I want you to go to stat test to sample z test. It'll probably give you an option for list or data or stats again. And you want to use stats because we don't have the data. We just have the results of the data. Do you see that?
Yep.
So you want to enter the sample mean for the first one, standard deviation, sample size, and then do it for the second one there as well.
The sample size would be 78, right?
Yes.
And then what does N1 stand for again?
The sample size. N1 is the sample size.
Oh, sorry. I was looking at X1 or Which one was X1? Sorry.
The middle one. Their sample mean is 47.
Okay. Oh shoot. I put 47 for the first one.
Yes, so that's the danger here. So okay, so notice this one is actually different. It wants sigma 1, sigma 2, right? So sigma 1 is 13, sigma 2 is 14. Then it wants X bar 1, that's 47, N1, which is 78. And then it wants X bar 2, which is 40, and then N2, which is 48.
Okay.
Now you again have this choice between not equal to, less than, or greater than.
Mhm.
So you got to look for the keyword here. Now I know I'm doing a bad job of not reading these, but the part you got to get down is putting the numbers in the calculator and then
Yeah.
deciding this. So significant difference, whenever you see difference, that's not equal to.
Not equal.
Okay, so that should be enough for you to calculate the test statistic. It says to round to 4 decimal places. It'll give you the p-value, also round to 4 decimal places.
Okay, so that's going to be behind the P, right?
You're going to get the t and then the p.
Okay, so T would be 2.8. Or shoot. I don't see a T. I calculated.
I'm sorry, a z. Sorry, z.
Okay. It just gave me 2.8.
Like exactly no other
Yeah.
numbers. Okay, that's all right. You can try that.
Let's see. Yeah, that's right. And then P would be 0.005. Let me try that. Oh, that was wrong.
Let me go ahead and calculate it here. See what I come up with. It didn't like the 2.8, or it did,
It did.
but it
but-
didn't like the p-value. So maybe just a rounding error. Let me get caught up here. I was trying to avoid doing this.
I can tell you what it gave me. It gave me 0.00511.
0.0051.
1.
Okay, so did you put in 0.0051?
I didn't put the 5 1. Let me try
Okay.
that. Okay, I got that. That one's right.
All right.
I thought 4 decimal places, so that was, I guess.
Yeah, to the right. Always think of it as to the right of the decimal point. Okay, now you have to compare to do part C here is you have to compare. Sorry, I'm getting it, trying to get it snipped in. You have to compare your p-value to the alpha level. Okay, so the p-value here is 0.0051, and that is that less than alpha? Is that less than 0.05? You have to decide if this is true or not. And the way you
if 0.05 is less than
0051, 0.0051, if the number you got, your p-value is your p-value less than the alpha level. So to do this, I would recommend writing them out with the same number of decimal places. And you go until one is different. Like, do you see how the 0 and the 0 are the same?
Yes.
But then this 0 is less than this 5.
Yes.
So that tells you it's less than. So this is true. When it's true, you reject H0.
Okay.
That has to be, tattooed in your brain for this course. P-value less than alpha, reject H0.
Okay. So
And then
the bottom one then.
Yeah, and the reject always means that there's a significance.
Okay. What are you? I know it's a weird question, but like, what does the reject mean?
No,
Like-
that's a good question. Like that's a core question in this class. So the whole basis of this class is you want to do a hypothesis testing. Like you believe something is different from the way that it is accepted.
Mhm.
Okay. So like think of H0 as what's accepted in our world,
Okay.
and HA is the like thing that you want to prove. Okay. Like
Okay.
we've all had ideas. We've all been like, man, every time I go to Chipotle, they underserve me, my chicken, right?
Uh-huh.
Or something like that. But the accept is that no, they're always giving you a scoop, right? And you're
Uh-huh.
like, no, I go in there and I get less than a scoop. Um, and I'm not speaking from personal experience. I'm just sort of making something up the top of my head. So like what you're trying to prove is that you're right. So when you reject H0, by rejecting H0, in many ways, it's almost like accepting this thing that you're trying to prove. The rejection leads to the acceptance of the other.
Okay.
Maybe too much information, but
No, no,
nevertheless.
no. I understand.
Okay. And in a more kind of, I guess, educational thing, they do this in science and they just research, but it's all comes down to hypothesis testing.
Okay.
Okay.
11.
So for this one here, you're going to use your calculator again. All right. Now notice that sigma is given. This time you're going to be using a Z, but notice they want a confidence interval. And guess what your calculator has? Confidence interval. Yeah. So let me find that for you. Let me go back to the calculator for that. So that's stat test. Let me write this down here in case you look at it later. Stat test. And you got to go down here past 7. So do you see 2 samp Z interval?
Yes.
So why is it 2? Because you've got 2 sets of data.
Okay.
Why is it Z? Because you have sigma. That's how you know.
Okay.
Now notice this time, and I don't know why it's out of order, but they give you X, they want X bar 1. So you're gonna have to update it here. X
That's
bar
under
1.
stats and not data.
Yes, exactly. Because you don't know the data. You just know the output.
Okay. So the first one is 28.
Yes, X bar 1.
And then 27. Oh, wait, sorry. I started at what is that little 0 looking thing again?
The sigma. That's
Sigma 1 is 14, right?
yeah, and
10. So it's 28.
oh, I'm sorry. It is in the same order as before. It's sigma 1, sigma 2. Wasn't looking. X bar 1 and 1.
It's nice that they show it this time.
Yes, yes.
Okay. And then I see sea level would be what's your sea level?
98.
Okay. Oh, I see. Do I have to put a 0 point or
You
point?
should be able to just type in 0.98. Make sure you hit enter though, or go down to make sure it takes it.
All right. So I got a little list of numbers: X bar 1, X bar 2, N1, and N2.
So when you calculate, there should be, the first one should be something in parentheses, and that's the confidence interval
Oh, I
here.
see. Negative 8.707
Okay. And then the other one
is 10.707.
Okay. So go ahead and try that. Make sure that works.
Oh, didn't like that.
All right, let me do this here. I didn't want to jump in until Had to on this one. It's probably a rounding error. If you put everything in correctly, they
Mhm.
don't seem too far off here. So sigma 1, oh, I see. Okay, there is a small thing here. See how it's sigma 1 squared?
Yes.
That
Oh,
means your
okay.
sigma 1 is the square root of 14.
Oh,
So
I
you have,
see.
so you have to actually do the square root in the calculation there.
Okay.
Let me snip that in so you can see it if you want. So that's a little annoying, but it's you have to take that square root down here, and then it'll calculate it for you. Like you can just hit enter and it'll do the calculation. And then sigma 2 is the square root of 10. Excuse me. And then x1 is 28, n1 is 17. Always a good idea to kind of double check you're entering it correctly, especially on a test. N2 is 17 as well. That's nice. Sea level is 0.98. Okay.
Yeah, I got a new answer.
Yeah, so I got minus 1.764
Yep.
and
Okay.
then 3.764 rounded, 3 decimal places.
Okay.
All right, just kind of scanning through the rest of this here to see what else you got.
Yeah, that one's right.
Awesome. All right, let's keep going here. I applaud you for trying to do the calculations. It can be kind of frustrating to see this.
I'm definitely getting better at this calculator ever
Yes.
since I've been doing lessons with you. So
Yeah, and then you'll find out you don't need it for the rest of your life, but you need it
yeah.
for this class. Okay, so the standard error of this, let me go back and look. Did we do a 2 sample t-test at some point? Yeah, we did. Does this give you the standard error? I can't tell. All right. So what I can't tell is whether the calculator will give you the standard error.
Okay.
Since I don't know, here's what you can do. You could put this into the 2 sample t-test. But what we're looking for, and I'm sorry for all the scrolling, when you do the 2 sample t-test, we're looking to see what's down below here. I
Okay.
guess I can search for that too. Let me do a quick search. Otherwise, we got to use just the formula. Sample t-test, TI, E4 output. They give you SX1, SX2. But
Sorry,
do
which
they?
one's the SX1 again?
All right, sorry. Go down, scroll down here. So this time they're giving you variance. So you have to take the square root of both of these.
Okay. $75. And then SX1 would be, sorry.
The square root of 75 for that, and then square root of 136.
So when I put the square root of 75 into X bar 1.
No, that's okay. So
Sorry.
what is the first thing you see on your list?
X bar 1.
X bar 1 is 47 in your problem.
Okay.
Sample mean is X bar.
Okay. And then do the square root of 75.
Yes. All right, I guess I better do this. I'm not finding the answer that I want here.
Are you gonna do it on the calculator?
Yes,
Okay.
because I don't like when I want you to do it as easy as possible, and it's easiest if you can get it from the calculator. So
Yeah.
let's see here, square root of 75 and 1 is 10.
I mean, do you think the other kids know how to do these calculations?
The teacher should be covering it in class. I don't know. I mean, I think it's an integral part of this course. Doing it
Yeah.
by hand is pretty brutal, but Some teachers are into pain and suffering. You can make your decision what you think. You don't need to know, like, it doesn't matter whether it's not equal to or less than. So pooled. All right, let me calculate that. All right, so moment of truth. All right, darn. Okay, so they do not give you the standard error after all that work. So I apologize for wasting that time there. So let me go grab the formula for you. Here it is. All right, so it'll look really familiar because it's a lot like the Z1. The standard error is this part down here. That's the standard error.
Okay.
So it's the square root of S1 squared. So these values of 75, that is S1 squared because it's variance. 10 S2 squared 136 over 16, like that.
4. That's definitely the easier way.
Yeah, sorry for going the wrong way,
Oh,
getting
no,
sidetracked.
I don't know any better.
Well, there's that, there's that curiosity of just like, well, I wonder if we can do it. All right, so here we go. Next question here. So this is a very common test question because it's easy to get the right answer. It's easy to get the wrong answer. It's just asking for what's called the degrees of freedom for the t distribution. Okay, and this has a known formula. And so I'm going to just go back to your formula sheet here and see if you actually get it. My guess is your teacher doesn't give it to you. Huh. Man. All right. Why wouldn't you get that? All this other things, but they don't give you that. Okay, so the degrees of freedom here is n1 plus n2 minus 2. So that's 10. Ooh, this one is not here, is it? Okay, that's because we're doing a pooled distribution. Okay, do you remember when we did the two sample? Actually, let me show that to you here. Do you see how we did the two sample t-test and there's this df right here?
Yes.
We want to do the same thing for this problem and get the degrees of freedom.
Okay.
So you're going to want to go to your two sample t-test in the calculator there, and then I'll kind of coach you through it here.
Oh.
So you should see x bar 1. That's 46.
Okay.
Sx1 is the square root of 75 this time. The reason it's the square root is because they're giving you the variance. So the standard deviation is the square root of the variance.
Okay.
N1 is 10. So a lot of these values are going to look similar. X bar 2 is 42. Sx2 is the square root of 119. N2 is 14.
And then not equal to, or
Doesn't matter for this one. Choose whatever you want. It doesn't have anything to do with the degrees of freedom calculation.
I got 21.68. So 21.7.
So they believe you round down on your degrees of freedom calculation. Give that a try. If that's not right, we'll do something different.
That is correct.
All right. So let me just look over the rest of this assignment here. Was the plan for tomorrow for us to go through the rest of this?
I mean, yeah, if we didn't finish,
15,
but I would like to
16,
do some,
17,
I could use some help on econ.
19, 20. Yeah, I mean, you're looking at most of a lesson here, maybe 30 minutes with some time left over to do some econ. I'm probably not going to be able to do anything else tonight. I'm sort of
Okay.
at my my breaking point here.